All right, welcome everyone. We're going to have a serious talk about AI here. I am just going to put into the chat room here though, because I didn't get to complete in the last one from our previous Asian panel. I just wanted to make sure that you had Dr. Cher Motorola, her email address as well. So I am just putting that into the chat room for everyone, because that was a great panel, and just feel free to reach out to them. So in just a moment, we're going to be having Jamie Sachs join us here. Jamie is the Senior Director of Education at UBTECH Education. That is a division of UBTECH Robots. And she's going to talk to us about artificial intelligence. And I think especially in terms of what has occurred since the pandemic, previously we all understood AI, but I think it took a whole different meaning. And so we've gone much more in depth with that. So in just a moment, we're going to have Jamie coming out to join us here. And we look forward in terms of engaging in this discussion. Again, for those that have just joined, don't forget to visit the booths, because at the end of the day, we're going to have a raffle. And so in each booth, you can leave your digital or your digital business card. Just sign that check-in book, and just to make sure that you can be entered for the raffle at the end. So without further ado, Jamie, I've been talking about you already.
I'm sorry, Kelly, my internet cut out for just a minute, so I think I'm ready to go. I think you're done. Okay, I am trying to get my PowerPoint into presentation mode. For some reason, that's not working, but let me see if I can fix that. Are you guys seeing the presentation mode now?
No, but it's working though. This is fine. We actually see the next slide. Sometimes there's a little bit of a glitch with that, so you should be good.
Okay. Well, you guys will get to see all my notes and everything, so that's fine. Okay. Let me. Oh, sorry, this is not participating well. It keeps kicking out. Not sure what's going on. Let me see if I can just make this larger. All right, can you guys see that?
That works. Yes, okay. That works.
Okay, sorry about that. Technical difficulties, everyone. Thank you so much for joining the session today. My name is Jamie Sachs, and I'm the Senior Director of Education for UBTECH Education. And you just saw a little video about some of the things that UBTECH does. But today, I'm actually going to be talking about teaching our students artificial intelligence and why we need to be doing it right now. So, first of all, kids are growing up surrounded by AI. We all know that. We're all surrounded by AI. Most of us started interacting with AI a little bit later, but our kids are not going to know anything different. They talk to Alexa, Siri, Cortana, Google Assistant. They play games with Siri. And actually, some of these Alexa and Cortana devices are actually making their way into classrooms. So they're not going to really know a different world other than machines that they can talk to, interact with, that will talk back to them. Smartphones are full of AI. I'm sure for those of you that have kids, you know the value of having that iPad or smartphone in a restaurant or a waiting room. And all of our kids know how to swipe. They know how to talk to the phone. All the smartphones these days have face recognition, Snapchat filters that the kids love to play with to put their bunny ears on, and the cute faces. All of us use recommender systems, sometimes whether we want to or not. If you're watching Netflix or YouTube or Hulu or any of those streaming services, you're very familiar with the recommender systems that says, because you watch this, now you might like this. On your Facebook feed, if you click on something on your Facebook feed, It will give you similar things going forward when you're shopping on Amazon. Whatever you buy, it will also say other people who purchase this also like these products and give you recommendations there. And then also on your Google search, when the ads are popping up on the screen, those are all using components of AI to influence. The next thing we see coming, cars that can drive themselves, almost. There is a lot of research going on with driverless cars, driverless trucks, all kinds of different vehicles. Unfortunately, we are seeing a lot of the test failures online, and it's really interesting to think about whether you would be comfortable driving in an automated car. I'm not sure that I would at this point, but our kids definitely will be, especially the younger ones. By the time they get old enough to actually be driving themselves, or even possibly before then, we're going to have driverless vehicles, and they're going to be comfortable with that because they won't have known anything different. So AI is coming, and we should be talking to our kids about it on a regular basis. I'm sure that when you've gone into a supermarket or some fast food restaurants, you've done the self-checkout. I'm sure you've all had that frustrating experience where you're in the self-checkout, you scan your item, you put it on the scale doesn't recognize your item, it says put your item on the scale. You're like, you say my item is on the scale, and you keep going back and forth with that. So not all AI is perfect, but it is coming. I'm sure you've seen the kiosks in Burger King, McDonald's. Those have definitely accelerated with the recent conditions over the past year and a half. With the pandemic, we're beginning to see more and more of those touchless, these are not touchless, but I guess interactionless opportunities to order, so that you don't have to interact with a person. You order at the kiosk and then you just go pick up your food. In fact, McDonald's is diving all into the AI game. This was in 2019. This was a news story that happened in 2019. McDonald's acquired a company called Apprente in California that creates voice-based platforms for conversational ordering. It's an AI company that trains intelligent agents through observations and interactions to have a conversational ordering experience with the customer. When McDonald's purchased Apprente, they actually started a whole new subsidiary of McDonald's called McD Labs. So they now have a whole technology arm to really accelerate their use of AI, voice recognition, face recognition in terms of ordering. So this is coming to your fast food restaurants. You are going to see less and less people in your fast food restaurants. And if you were in Dr. Pruitt's presentation yesterday, this absolutely supports what he was saying about the industries that are going to be, that have the potential for automation. I believe he said before the pandemic, food service had a potential for 69% of it to be automated. And after the pandemic, it was accelerated. And now there's a potential for 100% of food services to be automated. So all of these things are coming, and we need to make sure that our kids know how to use them. I actually went off on a little bit of a tangent yesterday also after I heard Dr. Pruitt's presentation. I actually went to a search engine. I think it was ZipRecruiter, and I just picked a state. I picked Texas because I'm sure you guys have all heard the stories about tech is coming to Texas and out of California. And I just searched for computer programmer jobs in Texas. As of this week, there are 38,290 open computer programmer jobs in Texas. And then I zeroed in on a city. I picked Houston. We've heard all the tech is going to Austin, so I wanted to pick a city that wasn't necessarily high tech. So I picked Houston. Right now, there are 5,435 computer programmer jobs open in Houston. And I dived in to see where those computer programmer jobs were located. Some of them were located at tech companies like you would expect, but these are the ones that I found interesting. waste management, which is garbage pickup, Lowe's, your hardware store, and Whole Foods are all looking for computer programmers. So everyone is getting into the automation game. Everyone is looking to hire programmers, not just the companies you would expect, but companies you wouldn't expect: McDonald's, Whole Foods, Lowe's, waste management. Then I dug a little deeper and I looked at all the job titles that were under computer programmer jobs in Houston, Texas. And one that stuck out for me was maintenance technician. You know, you probably expect all these others: full stack software developer, senior software engineer, software developer, project manager, even data scientist. But the one that stuck out for me was maintenance technician. So I'm like, maintenance technician under computer programmer was very interesting. So I dived into some of these specific jobs to see what they were. A lot of them were maintenance people at hotels, at government agencies. You see one here is a maintenance person at a brewing company. You know, and if you're an educator, this would be the maintenance person at your school or your district. The person who's doing the cleaning, making sure everything is running correctly, you know, keeping things moving as they should. So I looked a little deeper into these maintenance technician positions, and these are some of the required skills under maintenance technician positions. One really interesting thing is high school diploma or equivalent. So none of these are requiring any advanced education. No technical school, no college, no associate degree, no master's degree. And then the first things I noticed were, these are a lot of the 21st century skills. Be able to communicate effectively, strong analytical and problem solving because they are fixing things, ability to make decisions and solve problems. But then it got really interesting. Started seeing things about computer programming, experience with programmable logic controls, install, maintain, and troubleshoot, relay logic, ladder diagrams, control components, proximity sensors, limit switches, motor starters, basic ability to use a Linux command interface. That's computer programming. These jobs are looking for maintenance technicians who can work with computers and robots. Experience with robotic or electromechanical maintenance, perform advanced troubleshooting, knowledge of engineering and computer programs. So again, this is really supporting what Dr. Pruitt was saying yesterday. As I said, I went on a little bit of tangent looking at these things yesterday because I got inspired by his talk. So this is really a job that we would say only in the past required a high school diploma and nothing else. But you can see here from the requirements for these jobs that it is ramping up. People are expecting high school graduates to have a different set of skills in order for these types of jobs going forward. And I want to give you a specific example. This is a UBTECH product called ADIBOT. It's an autonomous UVC disinfection robotics solution. This is something that UBTECH Robotics has developed to disinfect classrooms, hotel rooms, hospitals, stadiums, anywhere where people gather. And obviously, this has become much more in a focus during the pandemic, right? Everybody's looking for ways to disinfect, make things cleaner. And if you look at the number of sensors that are on this machine, there's a LiDAR sensor, there's a camera recorder, there's a depth camera, there are motion sensors, there are all different kinds, ultrasonic sensor on this. And this is a device that would be used by your maintenance staff. In fact, we did a pilot at Christina School District in Delaware. And it is the maintenance staff who would be using this. They were so grateful for the pilot there because at that point, COVID was running crazy in their schools, right? And they would have someone in a classroom that would be testing positive for COVID. So they would have to evacuate the classroom, and they were calling it a hot classroom. And those maintenance workers were really taking a risk themselves by going in and having to clean that classroom by hand after someone tested positive for COVID. But with this device, you can send this device in, run it on a program around the room, and it will disinfect everything that the light touches. And we train those maintenance people how to use this device so that they don't have to go in the hot rooms anymore where something has been detected that's dangerous for humans. So it really is, again, my point is that it's really ramping up the skills that we are expecting our high school graduates to have. So it's really important that we are teaching our kids computer programming and AI, artificial intelligence, because we already live with autonomous robots. Some of you may have a Roomba in your home or other robot vacuums, and those have cameras, LiDAR sensors. Amazon's warehouses are full of Kiva robots that pick your packages and put them on the conveyor belts for delivery. And I'm sure we've seen the commercials about Domino's offering the robotic pizza delivery in the autonomous vehicle that drives up, the door opens, you just take your pizza out. So these are coming, they're already in our homes, and it's just going to accelerate going forward. So it's really important that we teach our kids about AI. So Andrew Ng, he is a researcher in the field of AI, talked about AI as being the new electricity, and it's powering the next industrial revolution, which again, Dr. Pruitt's presentation yesterday really talked about the fourth industrial revolution and how accelerated it's going to be in terms of programming and technology. It's going to bring huge economic and social change, and we need to be informed as citizens to understand issues that AI is raising. And as I mentioned before, children are growing up with AI, so they shouldn't think about it as magic. They should think about it as technology, and they should understand how it works and how it's used for good or not good. And then we just talked about how in the future, many jobs will involve working with AI in some way, interacting with intelligent agents, either through speech recognition, face recognition, sensors of some type, recommender systems, all of those things. So students really need to be prepared, at least to understand how it works and be conscientious consumers. So I hope that I convinced some of you that we need to be teaching our kids about this at this point. But now you might be saying, how do we even start to do that? Where do I go? I don't even know if there are any lessons for AI. So this is really all that currently exists in terms of standards, or up until this year, this is all that has existed in terms of standards about AI for K12 students. CSTA has computing standards that were developed in 2017, and I think they were revised in 2018. They only provide 2 sentences about artificial intelligence for K12 students, and both of them are for 11th and 12th graders. So nothing for our younger kids. It's described how artificial intelligence drives many software and physical systems. So basically that's a large overview of AI. And then implementing an artificial intelligence algorithm to play a game against a human opponent or solve a problem. That's a very specific application of AI, and that's all that currently exists in our computing standards that most of us look at when we're talking about teaching kids about programming. So there actually is a new game in town. It's an organization called AI for K12. It's a joint initiative of AAAI, which is the Association for the Advancement of Artificial Intelligence, CSTA, which is Computer Science Teachers Association, Carnegie Mellon University, and it's funded by the National Science Foundation. And they have been working for probably about 3 years on research. They work with MIT, USC, University of Florida, lots of other colleges and nonprofit organizations that are interested in teaching kids about AI. So they've been working with a lot of academia, doing research about how to teach kids about AI and what they should be learning. So they have come up with national guidelines for teaching AI in K12. They're modeled after the CSTA standards for computing education. So they look very similar to those standards, but they are completely focused on artificial intelligence, not computer programming, artificial intelligence. There are 4 grade bands. They have a K2 grade band, a 3.5, a 6.8, and a 9.12. And yes, you can teach elementary school children concepts that lead to artificial intelligence, and start to talk to them about how they're interacting with artificial intelligence. These guidelines talk about what students should know and what they should be able to do as they progress through K-12. Now, one of the big hurdles with developing these guidelines was the fact that there's not a lot of agreement about what artificial intelligence is. One of the original definitions was by Alan Turing when he created the Turing test. He proposed a test of a computer's ability to think by having a judge determine whether they were speaking through a screen to a human or a computer. And if the judge couldn't tell the difference, that computer was thought to be intelligent or thinking. Then later, another pioneer of artificial intelligence said, John McCarthy said, machines that can think autonomously are AI. Getting a computer to do things which, when done by people, are said to involve intelligence. Still pretty vague. And then today, Wikipedia says artificial intelligence is intelligence demonstrated by machines as opposed to the natural intelligence displayed by humans or animals. So again, there's definitely argument among scientists about what is artificial intelligence, but there are lots of technology and concepts required to create artificial intelligence. And that's what we can begin to teach kids about. And we can start to teach them about the ethics of artificial intelligence. So AI for K-12 has done a great job in creating a framework of 5 big ideas. And this is how they organize their standards for AI, teaching AI to K-12 students. They felt they have a large working group of teachers who are pioneers in this field. Again, as I said, academia, college professors who are working on this. And they felt that 5 big ideas are enough to cover the richness of the field, but small enough to be manageable by teachers. And also based on what CSTA learned when they were creating their standards, what we're teaching kids is not necessarily the way the AI practitioners might view their field, but it's very appropriate for a K-12 audience. So the 5 big ideas are perception, the way computers perceive the world using sensors, because we all know that in order to learn or act, we need information. So computers gather information through sensors. The second big idea is representation and reasoning. Once you can gather that information through sensors as a computer, then you have to create a representation or a model that you can use to make predictions. And then learning, once you've created those models, then you can learn from new data. You can start to, as a computer, make predictions, assumptions, even new theories can come out of the data that you're given. The fourth big idea is natural interaction. Can robots or artificial intelligence interact naturally with humans? So to a point that we can't tell the difference between a robot and a human. I'm sure you've seen some of the videos with the robots that have human-like faces that are sort of soft and malleable, and they speak and they can they make expressions. You know, if you've seen those, you know we're not quite there yet, but it's coming. People are working on it. And then the fifth big idea is really an overarching idea about the societal impact of artificial intelligence. So AI can impact society in both positive and negative ways, and we'll talk about those in just a minute. So these are really well organized into a small group of ideas that we can begin to teach our youngest learners about. Even in kindergarten, they can start to learn some of these ideas. So let's talk about each one of these big ideas. Well, first, if you're interested, if you go to aifork12.org, there is a poster that you can download for your classrooms, your school, your office, or just for yourself that describes each of these 5 big ideas. And this, I know we have a lot of people in the audience here from other countries, this is available. It's been translated into many different languages. So I'm sure you could find appropriate language for yourself there if you are from another country or speak a different language. So first big idea, perception. So again, we perceive the world through our senses: hearing, taste, touch, smell, 5 senses. Computers use sensors, right? So they use cameras, microphones, inputting data. Some of them have touch capability, speech recognition, and then they take that data and they do something with it. So as our world becomes much more transparent, computers are gathering lots and lots of data. As you can see, this is not in the US, this is in another country, where it's they're doing tests with facial recognition on people just walking down the street to gather information for computers. So as we get more and more cameras in our world, computers are going to be able to get more and more data through sensors. And once they get that information, then they have to extract meaning from that information, right? And how do they interpret that? And then how do they use that to make predictions? So that's one of the things that kids can start to learn. So if you're in kindergarten through 2nd grade, one of the things that you would start learning here is all about human senses and how they work and how the human brain makes sense of that information that we're bringing in. And then as you progress, you would start comparing that to the different type of senses that animals have. For instance, bats use radar. So that's a different kind of sense than a human has. So then you would start to compare that animals can have different types of senses than humans, and how does that work, and how do they get that information? And then you eventually get to computer sensors, right? So it's a progression, but the students need to have a deep understanding of human senses and animal senses and how they work in order to be able to equate that with computer sensors, and then understand how computers get information from that. So that leads to the next big idea, which is representation and reasoning. So once a computer or a robot takes in information from a sensor, they have to create representations of that, right? So they have to start of making some sort of sense of all the information that they're taking in. And they do this through algorithms or computer programs. And one of the things that students can do is start looking at creating models. So a representation is just a model of something, an organized model. So one of the things we have our K2 students do is create a family tree. So they create a family tree and they talk about how that represents their family and what can we infer from a person's drawing of a family tree. So we have the students look at each other's family tree and talk about what they are inferring from that. Like, what can you tell about your collaborator's family by looking at their family tree? And of course, they're going to get some of those inferences wrong. Like they might say, you know, Susie's brother is older than her because he's higher up on the tree, but maybe that's not true. Maybe Susie just drew that where there was a space, right? So you talk about how those inferences can be correct or incorrect, but really helping students understand what a model or a representation is and how to gather information from it. The third big idea is learning. So again, humans learn from experiences, but machines are also able to learn from experiences now through their sensors and machine learning, right? So we talk about in this section with kids, we talk about how computers can be taking a lot of data, right? Either input by humans, can be numerical data, or that sensor data. And then they can recognize speech or images through their sensors, and then they use algorithms to evaluate large amounts of data, and then they start to identify patterns in the data. So for instance, one of the activities that we have kids do is talk about what makes a tree a tree. Like, what does a tree have to have? What characteristics does it have to be a tree? You know, and then they might start saying things like leaves, bark, it has to be tall, and then you take these things and put them into a data set. Obviously, we're, writing them down for kids, and we look at them and we talk about that this is a data set. This is all the things we've come up with that make a tree a tree. Well, then you show students some pictures of unusual trees, like a pine tree, doesn't have leaves. Is it a tree? And you talk about how your inferences and what you learn from that data is really dependent on the kind of data you get. So if you don't have all the data, you might incorrectly identify something as a human or as a machine. For instance, if you grow up in a household that only has dogs, you've only seen pictures of dogs, but then you go to a friend's house and they have a cat. A very young child might call that cat a dog because they've only seen dogs. And that cat looks similar enough to a dog that they might misinterpret that. That actually happened with my son when he was about 2 years old. We went and visited a friend who lives on a farm, and they had some baby pigs, and the pigs started running around him, and he started calling them dogs because he had never really seen a pig in real life. He'd seen pictures of pigs, but still in the flesh, his first thought was, that looks like a dog. So, young children can make those same types of mistakes that our machines are going to make as they are gathering data from the world. The next big idea is natural interaction. This one is very hard. This one is going to require us to find a way to provide computers with different kinds of data. So this means that computers and robots are able to understand natural language. So I'm sure we've all had the experience where, you ask Alexa something and she doesn't understand what you said, right? Or if you are someone who has an accent, because English is not your first language, when you talk to Alexa, she may have trouble understanding what you're asking for. So that is a difficult hurdle for robotics and AI, is to really get to that natural language understanding. And if you think about it, our language doesn't just consist of the spoken word. It consists of facial expressions, body language. All of that has to be gathered in data for robots or computers to really have that natural interaction with the human. And again, I'll refer back to those robots that we've seen with the faces that look like skin, and they really can move their lips and their eyes. It's still not quite right. It's a really big hurdle for programmers. So one of the things we can do with students is talk about all the different things that are involved in communicating with another human. Of course, speech is one of them, but there are many different languages, right? So that's a complexity all on its own. If you're trying to talk with someone who doesn't speak English and you only speak English, that creates a barrier. Talking about facial expressions, body language, emotions, all of that. Human communication and language is very unpredictable. So this is going to be a difficult one for our AI researchers and programmers to overcome, but we can start talking to our students about the things that need to happen for a robot or a computer to interact with a human naturally. Oh my goodness, back to the beginning. Sorry about that. So students can really start to have a deep understanding of all of the ways that humans communicate, and start to think about how to apply that to a robot or a computer. And then the last big idea is societal impact. So there is a huge question about the ethics of AI making decisions about people, fairness, bias, accountability. I'm sure that you've all seen stories about AI that was created that is not exactly working as it was intended. So for instance, facial recognition used in law enforcement. So law enforcement is using more and more facial recognition, looking for people through the cameras on the streets, looking for suspects. And facial recognition software completely depends on the faces that the computer is given. So if a computer or an AI is given more white faces, it's going to have a very difficult time identifying black or brown faces or Asian faces. It's not going to be as accurate. So it's really unethical to be using this type of software when it has these type of biases in it. I'm sure there's a story a couple of years ago about, I think it was Google was trying to use an AI to sort through resumes because they get so many resumes. You know, a lot of people want to work for a company like Google, and it was just overwhelming the number of resumes they were getting. So they tried to actually use technology, create an AI that would sort through the resumes. And what they asked it to do was compare these resumes to the resumes of their most successful employees. And that created a huge bias for male applicants. Because as we know in STEM, there is a much lower percentage of females in the STEM workforce, especially computer programming, technology, AI research, those type of things, than in other careers. So it really was biased to pick out male applicants at a much higher rate than female applicants, and especially, you guessed it, white male applicants, Asian male applicants, Indian male applicants, because those are the highest percentages of people who are in those current jobs in tech companies. And they were asking the AI to compare the new applicants with the ones that they already had that were successful. And so it created a big problem with reviewing applications, and they actually dumped it and they don't use it anymore. So obviously this is a concept that's really hard to teach young kids about, K through 2. But what we can start teaching them about is how do your choices impact those around you, right? So how does what you do affect your classmates? So if I decide to just take off running down the hall, how does that affect my classmates that I bump into, right? So you really talk about how choices can affect others around you. Another aspect of the societal impact of AI is economic impacts of AI, right? So a lot of people, I'm sure you've heard this, and I think Dr. Pruitt mentioned it in his presentation yesterday, are thinking about all these things getting automated and people going away, right? And a lot of people think it's going to look like the picture at the top. You know, all robots doing the job, no human interaction. They're going to be able to do it much faster, much more efficient, much more precise than humans. But what it's really going to look like is something like at the bottom, right? We're going to have computers doing sort of the hard, laborious, tedious work, but we need humans to make sure that they're running efficiently, effectively, to fix them when they break down. So rather than jobs going away, the jobs are going to change. It's going to be a lot less of those jobs, as Dr. Pruitt mentioned, that only require that high school diploma. You're really going to have some understanding of programming, working with robots, working with technology. You know, as we saw in the maintenance technician positions, they want people who can work with these types of systems. So there are new career opportunities, but it is going to require some different skilling of people who are currently in these jobs right now, who need to shift away from actually doing the works that the robots do to managing robots. And I'm sure you've all seen this already. When you go to the self-checkout in the grocery store, there's always a person there monitoring, right? And if something goes wrong with your self-checkout, you can call the attendant over and they can help you with it. Or if you put your, you scan your item, you put it on the scale doesn't recognize it, and it keeps telling you to put it on the scale, put it on the scale, put it on the scale. Eventually, it's going to call the attendant over itself, right? So that's already happening in our grocery stores. You have a person there monitoring like 6, 10 self-checkouts in case there are any issues. And those are the different kind of jobs that are going to appear as we automate. And then the last thing is we have to think about how AI is going to affect culture, right? It's already affecting the culture of our children in that they cannot, a lot of them, cannot be separated from their devices. And some of us too, right? We start to get twitchy if we're separated from our smartphone or our computer or our iPad. We're constantly on there getting information. So that is already a cultural shift. But again, as I was talking about the self-driving cars, would you drive in a self-driving car right now, or would you let your children ride in a self-driving car right now? I don't think I would. But again, as our children grow up, it's going to become more and more commonplace, and they're going to be more and more comfortable because they've grown up with these things. Another thing that you have to think about with AI and culture, I'm sure you've heard the stories about, is Alexa listening, right? So is Alexa listening to the things that you say in your house and those conversations, and what are they doing with it? Also, I'm sure you've been talking about planning a trip to Cabo, and then all of a sudden on your phone, up pops a huge discount on a trip to Cabo. So that is definitely a culture shift, right? Of having something listening to everything you say and then providing recommendations based on that. I'm sure you've also heard some of the stories about when people have the cameras in their house and somehow hackers get into the cameras and they're watching things in their house. So there's definitely some scary stuff out there that we have to really consider when we're creating AI. But again, it's an awareness for kids, right? It's an awareness of how they're interacting with the AI, how it works. It's not magic. There's a programmer on the other end creating it, and there's someone providing it with data or programming how it evaluates that data or processes that data, and then what it does with that data. So really just getting our kids to be aware of how that is happening will make it less mysterious and less scary. So those are the 5 big ideas that are in the AI for K12.org standards that they've created. This will look familiar to you. This is a standards progression chart. I'm sure you've all seen these in your work in education. And so again, what they tried to do was create these 5 big ideas with the different concepts. And there's more than 1 page for this first big idea. I just copied the first page. I think there's 3 pages. So I think there's 6 concepts, maybe more. And it talks about what the learning objective is for the kids at different ages and what they should understand. So if you look across the top, just talking about sensing in living things. And then the next concept is computer sensors. So first we need to talk about, again, how living things sense and how it's different. So the first thing we talk about is human senses, right, for our youngest, and really talk about how senses work. How do we use those? And this really fits well and nicely into your integrated STEM activities, right? Because this is something kids are learning about anyway, is the 5 senses. You're really just giving them that extra step of, okay, so these are the 5 senses. Now, what do we do with that information? And really talking about it in terms of the gathering aspect, the processing aspect, and then making that tiny connection between, okay, robots have sensors too, and they can do that as well. And then as you go up, you'll see that it gets more advanced. So grades 3 to 5, here's where we talk about animals, and how they have different senses. So beginning to teach kids that different entities can have different type of senses because of what they need to operate in the world. So bats and dolphins use sonar, bees can see ultraviolet light, rats have no color vision, and so on. And then in grades 6 to 8, you talk about how humans combine information from multiple senses, right? So if you're eating something, what does it look like? What does it smell like? What does it taste like? And what does it feel like, right? And talking about what you do with all of those different inputs to evaluate whatever you're eating, and then so forth. So really laying this out really nicely to give kids a really solid understanding as they move from kindergarten all the way through 12th grade. And here is a little bump out of this. Again, big idea is perception. Computers perceive the world using sensors is what we're trying to get at. Perception is the extraction of meaning from sensory information, and the transformation from a signal to meaning takes place in stages with increasingly abstract features and higher level knowledge applied at each stage, right? So back to this, you'll see this across the top. And so this talks about the progression that kids are going to go through as they start to learn about human senses, computer senses, digital encoding, and how it gets more and more complicated as we move through the grade levels. And again, here's just the last example again about the sensors, about senses and how it progresses, right? So first they learn about human senses and sensory organs, then they can progress to comparing human and animal. People experience the world through sight, hearing, touch, taste, and smell, and some animals have different senses, and talking about how those work. So I hope that I've convinced you that we need to start teaching our kids about AI, if for no other reason other than they need to be conscientious consumers, informed consumers, and don't necessarily take all the recommendations that Facebook gives you or Amazon gives you, and understand why you're getting those recommendations. Also, as they advance into careers, they need to understand what they're working with. And as you saw from some of the societal impact slides, law enforcement is working with AI. Maintenance technicians are working with AI. Teachers are going to be working with AI. And so we all need to understand what this tool is doing for us and where the biases might lie so that we can really use it to the best of our ability. So if you want to learn about teaching your kids about AI, go to ai4k12.org, or you can come to UBTECH Education. We've actually taken the AI for K12 standards and created some introductory lessons on AI. And in the handout section of this session, you will find a couple of handouts. One of them is some of our sample activities from our curriculum. We give you one sample activity from each grade level, so you can take those and look at those. Obviously, if you go to ai4k12.org, you will find lots of other examples of activities that you can begin to use at all grade levels to teach your kids about AI. And then I also linked in the handout section a recent article in EdTech Digest where I sat down with Mark Gura from EdTech Digest to talk about teaching AI with kids. And so that also provides you with some links to ai4k12.org, some of our UBTECH AI information, and that can get you started on the road. And that is it. Thank you all for coming.
Thank you, Jamie, for providing us with such an insight on artificial intelligence. I know our participants really enjoyed it. If you see all the little fingers going up. So please check out the UBTECH booth. There's a lot of information there. And when we go into the networking portion, Jamie or a representative from UBTECH will be there, and they will explain further. Any last comments, Jamie?
No, thank you all for coming. Have a great conference going forward, and I hope to see you in person next year.
All righty, we will. Remember, Orlando 2022, Portofino. Take care. Have a good day.